Hi everyone, my name is Adrian Cidre and in this video we will create an awesome map of the distribution of Pinus sylvestris in Europe.
This is the map that we will create through this video, and it will be done completely in R. The data that I use for creating this map, it comes from the EU-trees4F dataset, which is a dataset of the current and future potential distributions of some tree species in Europe, and they are mapped at 10 kilometers of spatial resolution, and we will access this data by using a package that I developed which has the name of forest data. So in these two maps, in light red, we have the areas where the potential distribution of the Scots Pine or Pinus sylvestris is very low. So those are areas where this tree species is almost absent. Then we have these areas of light green where it's present, or at least the conditions are favorable for its presence. Then we have these areas of dark green, which are areas where it's expected to shift its potential distribution. So those are areas which are expected to become favorable for this species by 2095. And here we have two different climate scenarios, so the changes will be different in both scenarios. This is one scenario of intermediate emissions, and this is a scenario of high emissions. And finally, in dark red, we have the areas where it's expected to disappear. Okay guys, now we will go through the code that is needed to create the previous map. And in this script, I have 4 different sections. We will start by loading the packages, then we will load the necessary data, we will prepare this data for the visualization, and we will end up by creating the visualization. So in the first step, we will start loading the packages. We will start installing the development version of the forest data package. And since it's not in CRAN, we need to use the remotes package and install it from GitHub. So I will execute this and it will install the latest version. But since I already have it, it doesn't need to install it again. Then I will load the pacman package, and with the pload function from this package, I will load the rest of the packages, and we will use the forest data, ggtext, patchwork, terra, tidyterra, and tidyverse. So the next step, and I will start executing this, is to load the data. And I will use this function from the forest data package, which is fd forest utris4f. And here I have the help of this function, and you see that it downloads the data from this database, and it has some arguments. So here I'm using the species argument to download the data for the Pinus sylvestris, the Scots Pine. Then we have the period, and we have several options here. We can use one of these ones right here. And I'm using the current data, let's say from the 2005. Then I'm downloading for the two different climate change scenarios the data for 2095. Then I'm choosing to download the binary layer because we also have probability layers. So the binary layer will give us a raster of zeros and ones. And ones means that the potential distribution in that area is high. And zero means that the potential distribution is low, so is supposed to not be present. Then here in these other two functions, we are using a different argument, which is the scenario. Here, since we are using already current data, we are not in a climate change scenario. But since we are taking future data, we need a scenario. And here I'm taking this one, which is a scenario of intermediate emissions. And here we have a scenario of high emissions. And you see that I didn't use these two arguments in these two other functions because those arguments come by default. And you see that the first time that I execute this function is taking a while. It should take a couple of minutes or so. So I will pause the video and resume later. Okay, it has finished, so I don't need to pause the video. And here I will load the other two, but you will see that these two are faster. In fact, we already have this data downloaded, because what's happening is that we are accessing the dataset, and the first time you use the function is downloading everything because it's in a big file of 2 gigabytes or so. And then what you are doing is basically querying that big raster by using the rest of the functions. So we can see the structure of these rasters, and you see that it has these dimensions, the spatial resolution of 10 kilometers. We have the LIR Europe coordinate reference system. We have only one band, and we have the minimum value of 0 and the maximum value of 1. In the case that you want to replicate this exercise for a different species, you can check in the forest data package and run this U-trees for F species, and you will have a list of the species that are available there. So now we will go to the next step to prepare the data, and first what we need to do is to reclassify them. Because if you remember, in the final map we want 4 different classes, and each of these they have 2 different classes. But what we want is to compare the current data with the future data. So I want to compare this one with this one, and also this one with this other one. So when in this layer we have the value of 0 in one pixel, and it's still 0 in the same pixel of this layer, it means that the Pinus sylvestris was absent, and it's still absent. In the case that we have 1 here and 0 here, it means that the Pinus sylvestris was present, but in the future it won't be, and so on. But there is a problem to classify this. We don't have a case when function, we only have the if else. So we need to find another way to reclassify them. And what I did, it was to convert in these 2 rasters the values that are equal to 1 to converting to 2. And the values that are equal to 0, they will keep being 0. So then I will sum both rasters, and what I would be doing, it would be, in the case that in the first raster I have 0 and in this one I have 0, I will be summing up these 2 numbers. Then in the case that this one is 0 and this one is 1, I will be summing up 1. And in the case that this one is 1, then we'll have plus 0 and 1 plus 1. The problem that if I do this directly without using this, we will have only 3 classes, because this one would be 0, this one would be 1, 1, and 2. So these 2 classes would be exactly the same. So to solve this, I converted the class number 1 to number 2. So what we would be doing, it would be this. And in this case, we will have 0, 2, 1, and 3. So we would have 4 different classes. And if you didn't understand this, don't worry, I will do it step by step. I will call raster, this one right here. So if I execute this function now, we have a raster with value of 0 and value of 2. And then when I convert it to a factor, summing up these 2 classes, what I do is to get 4 different classes. I will have 1, 2, and 3. And finally, I access to the levels. So I go to the levels of this raster class. I take the first element of the list, because if you see here, this is a list. So with this I'm accessing the list, and with this notation I access to the second column. So I can change these levels by the classes that I define in the function, and these classes will be these ones right here. So now I will create this function. I will create these 2 vectors with the classes and the colors that I will use for the classes, and I will apply the function to both these layers, the ones from the climate change scenarios, not to the one of the 2005. So I execute this and I execute this. Now if I print this one, for instance, in the console, you see that the minimum value, instead of being 0, is absent, and the maximum value is present and stable, because we converted it to a categorical raster and we renamed the classes so they are not numbers anymore there. And now we can create a quick visualization to check that everything looks correct, and we see that it looks like. So we see that in Southern Europe the Scots Pine is absent, which is true. Then we have this reddish area, which are areas in where it will disappear. We have these green areas in the north, which are areas where it may appear. And finally, the areas where it's present and stable. And we can do the same for the other layer, and we can see there the differences. So now we will move on to the last part of this script, which is the visualization. And to create the visualization, I created this helper function that takes two different arguments. The first one is the data, because we need to plot these two different spot rasters, and then the title, which will be also different for each of them. So here I use the ggplot2 package. The layer that I use here, geomspat raster, comes from the tidyterra package. So here I introduce the data, and I say that I don't want to show the legend because we will use the labels in the title. Then I have this scale fill manual function where I specify in values the colors that we want to use for the map, which is this vector right here. Then we have the labels, which we actually don't need in this example because these labels are the ones that are shown in the legend. And since we are not using a legend, I can delete this. NA value is the color that we want for the NA values. So I don't want any color. So I set it to NA. And the NA translate is not needed here also because it's also for the legend. So I will delete this and I will align this back. Then here we have the labs function where I introduce the title, the theme void where I use this Roboto base family for the font, and finally I use some specifications for the theme. So I will execute this function and I will create the maps by applying the function to these two different rasters. And I can check if they worked well. So I will print the first one and there we have it. And the second one, there it is. So now we will move on to the next part, which is creating the title. And to create the title, I use the ggtext package. There is also a new package which is called marquee, but I didn't use this package. It's less verbose, but I found some problems when I wanted to create new lines for the title, and there was also a problem with the line height, so I stood with ggtext. And in ggtext, here I'm using the strglue function from the stringr package, and I'm creating these HTML tags where I set the style and I select the color that comes from the PS colors, which is the vector of colors that we defined before, which is this one here. So with these brackets, what I'm saying is that for this text, I want to take only the first color. That's why I'm using the number 1 here. And this is the text that I want to show, almost absent. Then we have the second color, which will be for decrease, which is this color here. Then we have the third color, which will be for the word shift, and is this color. And finally, the fourth color, which will be for the word present. And if I execute these 4 lines of code and I print one of them here, we see that this is an HTML tag with this style, and we are setting this color to the word present. So I use these as wrappers for the final title, which is this one here. And inside ggtext, we can use also other notation like these stars, which will make these two words in italic. Then I'm injecting again this text that I created before. And with this BR, we are creating line breaks. So I will execute this. I will print it in the console so we see how it looks. nothing very fancy. And now with the help of the patchwork package, we can sum up these two plots. So if I execute only this, it will assemble both plots by one at the left and the other at the right. And next, with the plot annotation function, I'm adding this title, I'm adding a caption, and I'm setting a theme for the final plot where I'm modifying the text, the plot title, the plot caption, and the background to be gray. So if I execute this and I print it now again in the plots pane, we should have the final result. And there we have it. I will zoom in and I will make this a bit smaller so we can see it better. And there we have our final result.